You're watching TelecomTV from the SDN World Congress 2016 event from The Hague. And I'm joined now by Shahar Steiff, who is AVP New Technologies at PCCW Global. Shahar, good to see you on TelecomTV again.
Thank you.
We've been talking for quite a few years about NFV and SDN, and we've seen its early development and implementation by the telecoms industry. For a long time, it seemed as if NFV was the solution to everything. It was the meaning of life for telecoms. It was the means to change everything and create a whole new paradigm for the industry. Is that really the case?
Well, you know, the myth out there was that NFV and SDN, to an extent, are the solution. You know, the panacea, the cure for all illness, for all sickness. And when we were trying to figure out what's there in NFV and SDN, they said, well, cost saving. Well, you know, I think we figured out already that the cost saving is something good, something that we need, but that's not what's going to save our business. What we really need is new revenue streams, and I think the market has come into a reality check in the last 3 years, and I think we see that here in this event. More and more people understand that SDN and NFV are not the goal. They are means. I would even say they're not, maybe not even the means. They're an implementation detail, an implementation example that allows us to get to the means, which will allow us eventually to get to our goal. Because let's look at it. Our goal is to be able to deliver on-demand services which are assured and measurable. Assured meaning we can manage class of service, we can manage bandwidth, we can manage security if required, we can manage the features of the service and not keep it as an on-demand service, best effort on-demand service. Because the current on-demand services are practically the public internet, which is seasonal. Sometimes it works, sometimes it doesn't. You can't really expect the behavior. So we want assurance, we want on-demand, and we also want to be able to measure, because measurements means the ability to later on bill. Who we bill is a different issue. You know, we might bill the end customer, we will bill the content supplier, but that's a different story. So the goal is to deliver those services, on-demand, assured, measurable. The means would be orchestrating the service end-to-end. And I think we're also starting to see the market understanding that end-to-end does not mean the two ends of your own network, because you can no longer deliver services on your own network alone. Services are becoming more and more complex. There are multiple domains, both internal and external. There are transport elements to the service where you convey information from one point to another, and there are features of the service which are happening at points. Could be the end point, it could be a midpoint, but things happen there. It could be packet filtering, it could be DSP processing that converts analog voice to digital, it could be a security feature, it could be data analysis or collection or storage. So these are, let's call them point services of some sort. These are the typical NFV services. Now, when you look at what NFV was and still is today, at least the practical implementations, they provide excellent solutions for those point services, for the applications. But they consider the transport, the connectivity as a given, which means either we're talking about public internet, which is a given. It's always there, always connected, with all the caveats of public internet, meaning insecure and unpredictable in terms of performance. Or alternatively, pre-existing connectivity, meaning a leased line of some sort, either a VPN or a fixed line, which has been pre-provisioned. And we all know that such circuits take weeks, if not months, to deliver, and therefore typically are also there for long, extended durations of time. So if you want to mix the ability of the on-demand internet with the predictability of fixed line services, which means creating those on-demand, assured, measurable services, if we're able to do that, we can now realize SDN and NFV functionalities. All those nice functionalities which exist already on NFV and add on the transport element that makes them a real end-to-end managed service.
You say if we can do that. Is the technology there today to do that?
Well, there it is. NFV and SDN are enablers, meaning without them, we surely cannot do that. Because without them, we will still be configuring devices manually, which we still do, by the way, in many cases. But we've already come way to be able to configure our own networks automatically or semi-automatically. Customers are already able to log into a portal and order services on demand. And some of those services already include both the connectivity element and the VNFs. PCCW Global, as an example, has already provided a product which includes both connectivity and a VM. And we're about to launch a product that includes connectivity and cloud service, which we will then be partnering with Azure and Amazon and Ali Cloud and maybe a few others. It's coming up. I mean, it's almost there. And we're not alone, by the way. You can see the same thing with guys like Colt and ANC and even AT&T are coming up with a similar product. So it's already happening. But keep in mind, those are all still confined to one single domain. Everything that has to be inter-domain is still manual, which means if the service goes beyond our own network, it reverts to manual. So we have beautiful automated silos, but the inter-silo communication is still done manually. And this is where SDN and NFV are enablers, but they're insufficient in order to really reach that nirvana of true end-to-end orchestration. For that to happen, we need to take a step ahead, and that's where I think the industry needs to focus in the coming years. And that is coming up with a true end-to-end orchestration solution, and for that we will probably need to align around three different matrices, three different directions. One is we will need to align around a unified information model, or maybe unified information models. And we talk about unified and plurals. That's obviously there's a contradiction in term, but bear in mind, information model for connectivity services is different than a information model for a point service, for security, for example, and different, even in connectivity, you have an information model for Ethernet, information model for IP, and you can have information models for layer 1 services. So still, we need to come into a unification of all those into a true unified information model. Why do we need that information model to be unified? Because if you want to exchange services across multiple domains, those domains need to speak the same language when it comes to defining the service. You cannot take a service that runs with a wheel on the right side and put it on a road in a country where people drive on the other side. It just doesn't work. You're not located in the right place, right?
So that's unified information models. That's the first one.
That's the first. That's
two
the
more
first
to
one.
go.
Yeah, 2 more to go. The other one is unified process, because bear in mind, if we do not have a unified process, I'm asking you to deliver an apple to Timbuktu, and or not even asking to deliver. I'm asking you, can you deliver an apple to Timbuktu? And if our information models are not aligned, if our process is not aligned, you will actually be shipping an orange to Geneva. Why? Because first, we don't speak the same language, so it's apples and oranges are not the same thing, but with lack of clarity, you don't know if I'm asking for an orange or an apple. Second thing, I just made an inquiry, and you interpreted that as an order, right? And so you already did the shipment. So you shipped the wrong thing to the wrong place when I haven't even asked you to ship anything. So this is why we also need a unified process, meaning we need to understand that there is an inquiry phase, there is an ordering phase, there is a delivery phase, a change management phase, or let's say operational phase, and there is a billing phase, and assurance phase, and maybe even cessation eventually if the service ends. And last but not least, we need to understand that there is an orchestration framework that we need to follow. We need to agree on a common orchestration topology. And keep in mind, there would typically be at least 3 elements, or at least 3 possible elements to an orchestration framework, which means obviously there's the customer, which could be an individual or an application or even a company or an enterprise. There would be a service provider. That is the entity that provides the service to the customer, whatever service it is. And that service provider might need partners to complement elements that they cannot deliver themselves.
Sure, yeah.
Each of those has their own internal structure. You know, there is the business functionality, there's the operation functionality, there's network management functionality, and those have different incarnations depending on the kind of service or the kind of part of service that this entity provides. Obviously, a cloud provider has a different internal structure than a connectivity provider. An application provider has a different structure. But all in all, we have those three major elements: customer, service provider, partner. And if we now superimpose process and service definition on this orchestration infrastructure, we come up with a real unified end-to-end orchestration. And I think without those three elements being aligned through a lot of standardization work, I mean, there's no way around it. We will need to get those things standardized, even if it's going to take two years.
This is my next question. I mean, we've identified information models, processes, the orchestration. Who does it? Who within the industry does this, and how?
You know, it will need to grow through the industry, through the actual players. There are many approaches. You know, personally, I think the most effective way, even though it is slow and tedious, would be to go through standard bodies. I know they're slow. I know they take time to deliver. But they can really comb through use cases and come up with a specification. You know, going through open source is certainly a way to speed things up, but I don't think it's a replacement because open source can only implement solutions. I mean, I would say the quality of an open source solution is just as good as the spec it implements. So yes, you can probably speed up the spec writing process through open source, but I do not think open source is a replacement for spec writing. You need to do the specs, and we need to understand it takes time. We need to try and make it faster. By the way, it will be much faster if we spend more focus and more energy on writing specs than on writing code. Because if you keep writing implementations of non-existent specs, we will come up with more. I mean, it's like herding stray cats, right? If we try and focus on directing the standard bodies to provide solutions to the real problems in hand, which are basically the inter-carrier, east-west kind of specs. If we try to focus there and spend less energy on finding southbound implementations, then I think we will be in the right place. Because southbound implementations, they're good, they're nice, but you know, anyone can deliver their. I mean, we've already done that. As we see, we already have southbound implementations, which means the in-silo, in-carrier solutions. Where we lack specs, where we lack progress, is on the inter-carriers.
The east-west.
East-west, exactly, on the inter-carrier. That's where we should spend our energy and our money, because I think that will actually get us to where we want to, which is, again, on-demand, assured, measurable services.
Shahar, absolutely fascinating. Let's hope we all can see and identify that goal and the means to get there. But for now, thank you very much.
Thank you.